Hello, and welcome to the Culinary Weights and Measures training video. The purpose of this video is to provide Virginia school nutrition directors and supervisors with the resources and guidance necessary to facilitate the 60-minute hands-on training module that was introduced during the 2018 Summer Manager Workshops. My name is Kelly Shomo, and I will serve as your host, providing guidance and instruction as you navigate your team through the module. You may implement this module alone or in conjunction with the other 4 videos in the 2018 Summer Manager Workshops series. For more information about the series, visit the Virginia Department of Education Office of School Nutrition website. Now, if you're ready, let's get started with Culinary Weights and Measures. Before your participants arrive, let's review the resources and supplies you will need to conduct the module. We can start with the digital resources that are available for download on the VDOE Office of School Nutrition website in the same location as this video. If you've not already done so, please download and, if desired, print the digital resources for Culinary Weights and Measures. For your convenience, the complete list of resources is now being shown on your screen. These include the Culinary Weights and Measures Video Instructor Guide, the corresponding participant workbook, 1 set of guiding practices, and 1 set of 30 bingo cards. If you need time to download the resources, you may pause or stop the video at this time. Now that you have the digital resources, it's time to prepare the learning area and gather additional supplies. The supply list is currently shown on your screen and may also be found in the instructor guide. First, each participant will need 1 to 2 pieces of scratch paper, 1 pencil, 1 calculator or their smartphone, and 1 4-ounce portion cup. You will also need a classroom or other learning area, tape for posting the guiding practices, 1 whiteboard or easel with flip chart paper, markers for writing on the whiteboard or flip chart, 3 to 5 sheets of parchment paper, 1 set of measuring cups, 1 set of measuring spoons, 1 kitchen scale, digital preferred, 1 dry measuring container, 1 liquid measuring container, 1 sieve or sifter, 4 small to medium mixing bowls, 1 bag or 8 ounces of leafy greens, 1 pound of all-purpose flour, 1 pound of dried beans, and 1 to 2 portioning tools of your choice. Once you gather all of your supplies, you can set up the learning area. First, arrange the seating so that participants may work together in small groups of approximately 4 to 6, if feasible, and provide each participant with the following supplies: 1 to 2 sheets of scratch paper, 1 pencil, 1 calculator, or they can use their smartphone, and 1 4-ounce portion cup. In each portion cup, add a small handful of the dried beans. Participants will use the beans to cover spaces on their bingo cards during that activity. Be sure to leave a small amount of dried beans for your demonstration station. Third, post the guiding practices on the whiteboard or wall so they are visible to all participants. Next, prepare your whiteboard or flip chart and add any items or information you wish to have ready ahead of time. At this point, you should be set up and ready to go. It's now time to pause the video and welcome your participants as they arrive. When you are ready to begin the module, press play. Hello, and welcome to Culinary Weights and Measures. In this interactive training module, you will have the opportunity to refresh and practice skills that are vital in nearly all food service operations, especially school nutrition programs that operate on tight budgets. Before we begin, please ensure that you have the following materials: a digital or hard copy of Culinary Weights and Measures participant workbook, 1 to 2 sheets of scratch paper, a pencil, a calculator or your smartphone, and a 4-ounce portion cup containing dried beans. Feel free to set the beans aside for now. You won't need them until the activity scheduled at the end of the module. Next, let's take a moment to review some guiding practices. These serve to maintain an engaging yet respectful environment that is conducive to learning. Guiding practice number 1 reminds us to attack the problem, not the person. Instead of focusing on the problem, focus on identifying potential solutions. Guiding practice number 2 encourages us to remain present, both mentally and physically. We all have busy schedules and lives outside of this training, but during the next hour, please try to focus on the material so that you get the most out of your time here. Part of that focus means silencing your cell phones and refraining from text and email. If you must make or answer a call, please do so away from the learning area so that you do not disrupt your colleagues. Guiding practice number 3 says to listen with an open mind. Instead of mentally preparing your response before another person is finished speaking, take a moment to digest what is being said and remain open to ideas different from your own. Finally, guiding practice number 4 reminds us to avoid side conversations. It's easy to get excited about something and want to share that excitement with your neighbor. However, side conversations disrupt learning and in some cases include information that might be valuable to the entire group. Okay, now that the formalities are out of the way, let's dig in. As you probably know, a solid understanding of basic mathematics is important for all school and child nutrition employees. In this module, we will review some of the basic yet important math skills we apply in our work. Consider, for example, measuring out ingredients for a recipe, using a scale, and adjusting a recipe's yield. All of those actions require math skills. As such, the focus of today's lesson will be the foundational skills necessary for a successful food service operation. Please note that the purpose of today's math lesson is to review and practice fundamental skills. You may notice unique quantities or units that are not common in child nutrition settings. Don't focus on whether the numbers are realistic, but rather on practicing your math skills. At the conclusion of this module, you should be able to meet the following objectives. 1. You should be able to add, subtract, multiply, and divide fractions for food preparation and recipe adjustment. 2. You should have an understanding of the importance of and be able to perform accurate measurements in food preparation and service. And finally, you should be able to use the factor method to adjust recipes. Now, some of you may find math a little scary or intimidating, but hopefully at the end of the module, you'll feel a little more comfortable using the culinary math skills needed to do your job. For those of you who feel comfortable working with math problems, allow this module to serve as a refresher and do not hesitate to assist others who might find the math problems more difficult. It's important to remember that everyone has a different learning style, and when working with math problems, there's often more than one way to find the solution. So if you have a method of solving a problem that differs from the method shown in this video, please share this with your group. Finally, do not hesitate to pause the video if more time is needed to complete tasks or engage in discussion. Okay, let's proceed to a brief review of fractions. At this time, the instructor should prepare to pause the video for a discussion. Now, take a moment to consider the importance of fractions in food preparation and service. Think about the tasks you perform in your workplace that involve fractions. You may now pause the video and take a few minutes to share answers and discuss. As you can see, fractions are involved in a variety of food service processes. Some examples you may have discussed include weighing and measuring ingredients, adjusting recipes, and taking inventory. Now, as you probably already know, standard calculators are not very helpful when working with fractions. Instead, you can use scratch paper to follow along and work through problems during today's training. But before we get into problem solving, let's start by identifying the purpose of a fraction. A fraction is simply a way of showing the relation between a part and a whole. For example, If you cut an apple into 4 pieces and then ate 1 piece, you ate a quarter or 1/4 of the apple. That is, you ate 1 part or 1 piece of the whole or 4 pieces. Next, let's cover some terminology. Fractions have a numerator or top number and a denominator or bottom number. Fractions may also be different yet equal in cases where they can be reduced to their lowest term. For example, you can see in this diagram that 4/8 is equal to 2/4, which is equal to 1/2. 1/2 is the lowest term. To reduce fractions to their lowest term, find a number that will divide equally into both the numerator and denominator. In the example we showed you, we know that both 4 and 8 can be equally divided by 2. When we do that, we get 2/4. In this case, we can reduce even further because both 2 and 4 can be equally divided by 2 again to give us 1/2. While this example is so simple, you can do the math in your head. Here are a few tips for reducing larger and more complicated fractions. First, if both the numerator and denominator are even numbers, we know that they can be divided by 2. Second, if both the numerator and denominator end in a 5 or a 0, we know that they can be divided by 5. And third, if both the numerator and denominator are multiples of the same number, then they can be divided by that number. For example, with the fraction 16/24, or 16/24, we can see that both the numerator and denominator are multiples of 8. 8 times 2 gives you 16, and 8 times 3 gives you 24. Therefore, you can divide both the numerator and denominator by 8 to reduce the fraction. Now that we understand what fractions are and how to reduce them to their lowest term, we can move on to addition and subtraction. Let's begin with the simplest type of problem, which is adding or subtracting fractions with the same denominator. Take a look at the problem, 1/8 plus 5/8. How would we solve this? Pause the video and discuss the process for solving the problem. Since you have 2 fractions with the same denominator, you simply need to add the 2 numerators and carry over the denominator. This gives you 6/8. However, 6/8 is not the final answer. In fact, you still need to reduce 6/8 to the lowest term. Based on the fact that both 6 and 8 are even numbers, we know that they can both be divided by 2. When we do this, we get 3/4, which is our final solution. We will follow the same process when subtracting fractions with the same denominator. The only difference is that we will subtract the numerators instead of adding. Let's quickly run through an example. What is 10/16 minus 2/16? Pause the video and take a moment to solve the problem. Okay, let's see how you did. Using the same method we used when adding fractions with the same denominator, we could subtract 2 from 10 and carry over the denominator to get 8/16. Because 8 and 16 are both multiples of 8, we know that both can be divided by 8. When I divide both the numerator and denominator by 8, I get 1/2, which is the lowest term and final answer. Now, let's move on to a slightly trickier problem that involves adding fractions with different denominators. Pause the video and take a few minutes to discuss how you might solve the problem 1/5 plus 2/3. Okay, let's review. When adding or subtracting fractions with different denominators, we can follow 3 simple steps. First, we need to cross multiply. For our problem, this means multiplying 1 and 3 and also multiplying 2 and 5. When we multiply 1 and 3, we get 3. When we multiply 5 and 2, we get 10. That brings us to step 2, which is adding the 2 products or answers, 3 and 10. This gives us 13, our new numerator. Now we need to find our new denominator, which is known as the least common denominator, or the smallest number into which both the original denominators can be evenly divided. This is step 3. To find the least common denominator, we simply multiply the original 2 denominators. For our problem, we would multiply 5 and 3, which gives us 15. 15 is our new denominator, which makes our answer to the problem 13 over 15. There are no numbers that evenly divide into both 13 and 15, so no reduction is needed, and 13/15 is our final answer. Okay, let's practice what we just learned. Pause the video and take time to solve these 2 problems. Remember, subtracting fractions with different denominators follows the same method as for adding, only you subtract instead of add the 2 products that give you your new numerator. Let's see how you did. We'll begin with the problem 1/6 plus 7/15. Step 1 is to cross multiply. In this problem, we need to multiply 1 and 15 and then 7 and 6. 1 times 15 gives us 15 and 7 times 6 gives us 42. This is an addition problem, so for step 2, we need to add the 2 products together. When we add 15 and 42, we get 57. This is our new numerator. Now we can complete step 3, which is finding the least common denominator by multiplying the 2 original denominators. When we multiply 6 and 15, we get 90 for our new denominator and 57 over 90 as our answer. In this case, we can reduce our answer because 3 can be evenly divided into both 57 and 90. When we divide the numerator and denominator by 3, we get our final answer, 19/30. Next, let's review the second problem, 2/3 minus 3/10. Step 1 is to cross multiply. 2 times 10 gives us 20, and 3 times 3 gives us 9. Now, since we're working with a subtraction problem, we will subtract 9 from 20 instead of adding the 2 products for step 2. In step 3, we find our least common denominator by multiplying the 2 original denominators. 3 times 10 gives us 30. 30 is our new denominator, which gives us an answer of 11 over 30. We cannot reduce this any further, so 11/30 is our final answer. Now that we understand how to add and subtract fractions with the same or different denominators, we are ready to review one other type of addition-subtraction problem. The type of problem I'm referring to involves mixed numbers, meaning a whole number and a fraction combined. Examples of mixed numbers include 1 and 3/4, 5 and 1/3, 2 and 3/8, and so on. To more easily solve problems involving mixed numbers, we can convert the mixed numbers to improper fractions. An improper fraction is simply a fraction that has a larger numerator than denominator. For instance, 5/3, 10/7, and 8/5 would all be considered improper fractions. How do we convert mixed numbers to improper fractions? We follow 3 simple steps. In step 1, we multiply the whole number by the fraction's denominator. In step 2, we add that product to the numerator. In our example, we will add 15, the product, to 2, the numerator. Then, in step 3, we write the result on top of the denominator. And just like that, we have our improper fraction, 17/5. Once we convert all of the mixed numbers in a problem to improper fractions, we can follow the same steps we just learned for adding and subtracting fractions. Let's go through one example. How do you solve 1 and 3/4 plus 1/3? Pause the video and discuss the process for solving the problem. Okay, Let's review the process for finding the solution. First, we need to convert 1 3/4 to an improper fraction. To do this, we simply multiply the denominator, which is 4, and the whole number, which is 1. 4 times 1 gives us 4. Next, we add that 4 to the numerator, which is 3. 4 plus 3 gives us 7, which is our new numerator. Now we have an improper fraction of 7/4. Our revised problem is 7/4 plus 1/3. The first step in solving this problem is cross multiplication. 7 times 3 gives us 21, and 1 times 4 gives us 4. Next, we add the two products together to get 25, which is our new numerator. In the final step, we need to find our new denominator. To do this, we find the least common denominator by multiplying the two original denominators. In this case, 4 times 3 equals 12. Now we have an initial answer of 25 over 12. Even though nothing can divide evenly into both 25 and 12, we are still left with an improper fraction. Thus, we need to convert our solution back into a mixed number. To do this, we divide 25 by 12, which gives us 2 with 1 left over. So our final answer is 2 and 1/12. Okay, you made it through adding and subtracting fractions. Now we can move on to the processes for solving multiplication and division problems, which are actually a bit easier. Let's begin with multiplication. For example, how might you solve the problem 5/6 times 4/9? Pause the video and take some time to discuss possible solutions. Okay, let's review. Finding the solution to multiplication problems with simple fractions is very straightforward. You simply multiply the two numerators and then multiply the two denominators. For our problem, we would multiply 5 and 4, which gives us 20, and 6 and 9, which gives us 54. So our initial answer would be 20 over 54. In this case, we can see that our initial answer can be reduced because both 20 and 54 are even numbers that can be divided by 2. 20 divided by 2 gives us 10, and 54 divided by 2 gives us 27. Thus, 10/27 is our final answer, since this fraction cannot be reduced any further. Let's practice one more of these. Pause the video and take a few minutes to solve the problem. 5/8 times 3/5. Let's see how you did. To solve this problem, you first need to multiply the two numerators and then multiply the two denominators, which gives you your initial answer. In this problem, you multiply 5 and 3 to get 15, and then 8 and 5 to get 40. This gives you an initial answer of 15 over 40. Because both the numerator and denominator end in a 5 or 0, we know that both can be divided by 5. When we divide 15 by 5, we get 3. And when we divide 40 by 5, we get 8. Therefore, our final answer would be 3/8. Should you encounter multiplication problems with mixed numbers, you would simply need to convert those numbers to improper fractions prior to completing the multiplication process. Now we can proceed to the process of dividing fractions. Like we did for multiplication, pause the video and take a few minutes to discuss how you might solve the problem 3/4 divided by 5/6. All right, let's review. The process for solving division problems is nearly identical to that for solving multiplication problems, with the addition of just one step. Prior to multiplying the numerators and denominators, we must first invert or flip the second fraction. Once we complete that step, we can change the divide sign to a multiply sign and follow the same procedure as we followed for the multiplication problems. In this case, we would multiply 3 and 6 to get 18, and then 4 and 5 to get 20. This gives us an initial answer of 18 over 20, which we know we can reduce because the numerator and denominator are both even numbers. When we divide 18 and 20 by 2, we get a final answer of 9/10. Let's try one more division problem. 3/8 divided by 3/5. Pause the video and take some time to find the solution. Let's quickly review the solution to the problem 3/8 divided by 3/5. The first step is to invert the second fraction, which in this case is 3/5. Once inverted, we can replace the division sign with a multiplication sign and solve for the revised problem, 3/8 times 5/3. To solve, we simply multiply the two numerators and then multiply the two denominators. In this case, 3 times 5 is 15, and 8 times 3 is 24. This gives us an initial answer of 15/24. Because both 15 and 24 can be evenly divided by 3, we can reduce the fraction to 5/8, which is our final solution. This concludes the first section of culinary weights and measures. You may now pause to take a break or proceed to section 2, converting fractions and decimals. Welcome back to Culinary Weights and Measures. Now that we have reviewed the purpose and importance of fractions and spent some time practicing addition, subtraction, multiplication, and division, we can move on to an equally important concept, which is converting fractions to decimals and vice versa. Take a moment to think about the tasks you complete in your workplace that involve this type of conversion. Pause the video and discuss. Some of the tasks you may have discussed include weighing and measuring ingredients, preparing recipes, and recipe adjustment. For example, if a recipe calls for 1.25 cups of flour, you may want to convert the decimal 1.25 to a fraction in order to measure out the flour using standard measuring cups. Let's review the process for converting decimals to fractions. First, you need to consider the place value of the decimal digits. For instance, let's forget the 1 for a moment and consider the 0.25 in our example. The 2 is in the tenths place, and the 5 is in the hundredths place. If there were a third number after the 5, that would be in the thousandths place. To convert 0.25 to a fraction, we would make the digits to the right of the decimal our numerator. Next, we would determine the place value of the last digit of the decimal, which in this example is the 5 digit, which is in the hundredths place. Because our last digit is in the hundredths place, our denominator will be 100. This gives us an initial fraction of 25/100, which can be reduced to 1/4 by dividing both the numerator and denominator by 25. Now, let's go back to the original problem, which was converting 1.25 cups of flour to a fraction. Here, you would simply add the whole number, or the number to the left of the decimal, to the fraction to create a mixed number of 1 1/4 cups of flour. Okay, let's get some practice. Pause the video and take a few minutes to work on converting 2.4 to a fraction. Let's review the process for converting 2.4 to a fraction. First, we can ignore the 2 digit to the left of the decimal. Next, we can identify the digit 4 to the right of the decimal is in the tenths place. Therefore, we know that 4 will be our numerator and 10 will be our denominator. Since both 4 and 10 are even numbers, we can reduce this fraction by dividing by 2. This gives us 2/5. In the final step, we can add the whole number, which is 2, to the fraction, which gives us a final answer of 2 2/5. Now that we reviewed converting decimals to fractions, let's discuss converting fractions to decimals. This process is much simpler because we can use a standard calculator to perform the conversions. Take the example 3/5. When asked to convert a fraction to a decimal, remember that the line between the numerator and denominator can also serve as a division sign. In this example, we would divide 3 by 5 on our calculator, which would give us 0.6. At this point, we could perform an additional conversion if needed. We could multiply our decimal by 100 to convert the decimal to a percentage. In this case, 0.6 times 100 gives us 60%. As you can see, conversions are integral to a wide range of tasks and duties in the kitchen. In the next section, we will see how the accuracy and consistency of calculations and conversions impact our program as a whole. This concludes section 2. You may now pause the video for a short break or proceed to section 3, weighing and measuring. Welcome back. Now that we reviewed fractions, decimals, and conversions between the two, we can begin to apply those math skills in the weighing and measuring section. But first, let's define the terms weighing and measuring. Remember, there are many forms of measurement, one of which is weight. Other forms of measurement include things like time, speed, and volume. When we talk about weighing, we are referring to measuring an item's mass using a scale. In food service, we work primarily with two forms of measurement, weight and volume. The two measures or units of weight are ounce and pound. Conversely, there are 7 measures or units of volume. These include teaspoon, tablespoon, fluid ounce, cup, pint, quart, and gallon. It is important to remember that volume is the amount of space an object or ingredient takes up. Weight is referring to an object's mass. Consider this question when visualizing the difference between weight and volume. Which weighs more, a pound of rocks or a pound of feathers? The answer is that the two items have equal weight. However, the amount of space taken up by a pound of rocks will be vastly different from the amount of space taken up by a pound of feathers. It is for this reason that weight is the most accurate form of measurement for solid ingredients in quantities greater than 2 ounces, and even for some liquid ingredients. Typically, however, liquid ingredients can be measured with liquid volume measures. Now consider one other example that demonstrates weight as the more accurate method. Say you needed to measure out 4 pounds of flour. If you measure this amount of flour with a measuring cup, which is a volume measure, you incorporate the potential for human error. Are you, for example, reaching into the bag with a 1-cup measure? Or are you spooning the flour into the measuring cup? Is every person on your team using the same technique that you are? These slight differences matter, especially when measuring large quantities of ingredients. Now that we have discussed the importance of using the appropriate measurement tool for the job, you will have an opportunity to see the concept in action with a live demonstration. The instructor may now pause the video and follow the instructions in the instructor guide to conduct the demonstration. Welcome back. I hope that you were able to gain further insight into the difference between weight and volume, as well as the importance of using the appropriate measurement tool and technique for the job. Let's quickly review some key takeaways. First, weight refers to an ingredient's mass, whereas volume refers to the amount of space that an ingredient takes up. Typically, weight is the most accurate form of measurement with solid ingredients and even some liquid ingredients. Second, if a scale is not available for measuring dry ingredients, be sure to use the largest appropriate measuring container to reduce opportunities for human error. For example, measuring 4 cups of flour in a single measurement using a graduated dry measure is more accurate than using a 1 cup measure 4 times. The standard sizes for graduated dry and liquid measures are 1 cup, 1 pint, 1 quart, 2 quarts, and 1 gallon. Dry measures larger than 1 quart are typically not used because weighing is more accurate. The rings on the graduated measures can indicate 1/4, 1/3, 1/2, and 3/4 of the total volume of the container from bottom to top. The measure shown here indicates 1/4, 1/2, and 3/4 of the total volume of the container, which is 1 quart. You can tell the difference between dry and liquid graduated measures by looking at the rim. Liquid measures will have a curved lip above the fill line to prevent spilling and make it easy to pour, whereas dry measures have a straight rim for leveling off ingredients. Third, be sure to use proper measuring techniques when using volume measures. For example, flour should be lightly spooned into a measuring cup or container and then leveled off with a straight-edged spatula. You should not tap or shake the measuring container, as this will pack the flour, leading to inaccurate measurement. And finally, remember the distinction between an ounce, which refers to weight, and fluid ounce, which refers to volume. Now, let's say that you are reviewing a recipe and you notice that the dry ingredient quantities are listed in volume instead of weight. You know that you need to measure these ingredients by weight to ensure accuracy and produce a consistent product. What should you do? In cases such as this, you may need to perform measurement conversions. This is where your background in decimal fraction conversions can be useful. That said, be mindful of the fact that equal volumes of 2 ingredients will not have equal weight. For example, 1 cup or 8 fluid ounces of apple cider weighs 8.7 ounces. Similarly, 1 cup or 8 fluid ounces of pudding weighs 10.1 ounces. Luckily, there are a variety of conversion charts available for quick reference, including the at-a-glance poster that has been included in your participant workbook. Just remember that measurement conversions are approximations and can impact the quality and yield of a recipe. As such, they need to be tested during the development of standardized recipes. We have reached the end of Section 3, Weighing and Measuring. The instructor may now pause the video for a break or additional discussion and then continue to the next section, Standardized Recipes and Recipe Adjustments. Welcome to Section 4 of Culinary Weights and Measures, Standardized Recipes and Recipe Adjustments. Before we begin, please take a moment to consider this question. What is a standardized recipe? Go ahead and pause the video and take some time to share out and discuss. Okay, let's review the definition of a standardized recipe. A standardized recipe is a recipe that has been tested repeatedly and produces the same yield and quality when the same ingredients, equipment, and procedures are used. Notice that simply using a standardized recipe does not ensure a quality consistent product. The end result relies just as much on the person preparing the recipe as it does on the ingredients and procedures listed. This is where using appropriate measuring tools and techniques can make all the difference. It is likely that most, if not all, recipes you use in your school nutrition programs have been standardized, with many of the recipes adjusted to yield 50 or 100 servings. But what do you do, for example, if you only need 25 servings? What about if you need 300 servings? The answer is that you have to perform a recipe adjustment. In other words, you have to adjust the quantity of each ingredient so that the recipe yields the desired number of servings. So, how do you do this? Well, there are a few ways you can accomplish this, but we will apply the method that is standard in the food service industry, the factor method. The factor method is simply a formula used to convert the original recipe yield to the desired recipe yield. Many of you are likely already using this method, you just may not call it the factor method. Now, let's review how it works. First, I want to note that tools such as the factor method recipe adjustment worksheet that I will use in today's example can really help keep you organized during the adjustment process. A copy of the worksheet has been included in the participant workbook for your convenience. Also, the instructor should be prepared to pause the video throughout the recipe adjustment example to give everyone plenty of time to review and understand the calculations in each step of the process. Now, the first step of the factor method is to identify the current recipe yield and the desired recipe yield. In this example, I have a USDA lasagna with ground turkey recipe that yields 50 servings. I need to adjust the recipe to obtain my desired yield, which is 300 servings. As you can see, I added this information to my recipe adjustment worksheet. Now that I have my current and desired yields, I can proceed to step 2, which is determining the conversion factor and listing out all recipe ingredients with their current quantities. For the conversion factor, all you need to remember is what you want divided by what you have. In other words, your desired yield divided by your current yield. In this example, I divided 300 servings by 50 servings to get a conversion factor of 6. Now, before I multiply all of my original ingredient amounts by the conversion factor, I want to convert as many of the original amounts as possible to a single unit of measurement. For example, the original amount for raw ground turkey was 3 pounds, 6 ounces. To streamline my calculations, I converted the pounds to ounces. I repeated such conversions for remaining ingredients as needed. Now I can move to step 3 and multiply all of the original ingredient amounts by the conversion factor, which is 6. As you can see, I added all of this information to my recipe adjustment worksheet. In step 4, we review the new amounts and convert to amounts normally used for recipe production. For example, my new amount for raw ground turkey is 324 ounces. To convert this quantity back into pounds and ounces, I simply divide 324 by 16, which gives me 20.25 pounds or 20 pounds 4 ounces. Now, we have one last consideration before the recipe adjustment is complete. We have to consider the seasonings or herbs and spices in our recipe and the extent to which we are increasing or decreasing those seasonings. As a general rule, the same conversion factor may be used for recipes yielding 100 servings or less. However, once you increase the recipe yield above 100 servings, you should use a different conversion factor for the seasonings. In these cases, you should increase your seasonings by 25% for each additional 100 servings. Let's go back to our lasagna recipe to see how this works. There are several seasonings included in this recipe, and because we are increasing the recipe above 100 servings, we know that we will need to increase the seasoning amounts by 25% for every additional 100 servings above our initial 100 servings. However, we are starting out with 50 servings. So first, we need to double the amount of each seasoning to get us to 100 servings. Then we can take the amounts needed for 100 servings and increase those amounts by 25% to reach the amounts needed for 200 servings. Once we have the amounts needed for 200 servings, we want to again increase by 25% to get the final amounts which are needed for our 300 serving recipe. Let's go through this together step by step. Here is the lasagna recipe adjustment worksheet with only the seasoning ingredients included. In the first step, we need to double our seasoning amounts to get to 100 servings. This has been noted on the worksheet. There is no need to adjust or round our new quantities until we reach the final adjustment stage. Now, at this time, the instructor may prepare to pause the video. During the pause, participants should complete the next adjustment, which is to increase the seasoning amounts from 100 servings to 200 servings. Remember, now that we are increasing above 100 servings, we only increase each amount by 25%. The instructor may now pause the video and participants may begin calculating the next adjustment for all seasonings. Once participants have finished calculating, discuss the answers as a group. When everyone is ready to review the answers, the instructor may press play. Okay, let's review the process for step 2 of our seasoning adjustment, which involves increasing seasoning amounts from 100 to 200 servings by increasing each amount by 25%. The first thing we need to do is to calculate the figures that equal 25% of each ingredient amount. To do this, we simply multiply each of our original ingredient amounts by 0.25. Once we have those figures, we need to add those figures, which again equal 25% of our original amounts, to our original amounts. For example, you can see on the worksheet that we multiplied the original amount of garlic powder, which was 16 teaspoons, by 0.25 to get 25% of 16 teaspoons, which is 4 teaspoons. Next, we added the 4, or 25% of 16, to our original amount of 16 teaspoons. This gave us a new amount of 20 teaspoons. Now take a moment to review the remaining answers and compare with your individual answers. You may pause the video to review and discuss the answers as needed. Remember, we will adjust and round ingredient amounts during the final step. Welcome back. We can now move on to step 3, which involves repeating the process for step 2 in order to increase the seasoning amounts from 200 servings to 300 servings, which is our desired yield. Use the worksheet currently on the screen to guide your step 3 calculations. Go ahead and pause the video, individually calculate the new ingredient amounts for 300 servings, and then discuss your answers as a group. When you are ready to review the answers, press play. Okay, let's see how you did. Take a few minutes to review the answers to step 3 of the seasoning adjustment process and compare those answers with your own. You may pause the video for additional review time as needed. We are now at the point where we have the amounts we need to produce 300 servings of the lasagna recipe. However, you probably noticed that most of the amounts are in quantities that are incompatible with standard measuring tools. To remedy this issue, we need to complete one final step, which involves adjusting or rounding quantities to those applicable to food service. Go ahead and pause the video and take some time to adjust and round the new ingredient amounts as needed to align with standard food service measuring tools. Then share out and discuss individual answers as a group. Press play when you are ready to review the final answers. Let's review the final seasoning amounts needed to produce 300 servings of lasagna. We can start with the adjustment and rounding for garlic powder. As you can see, our final amount for 300 servings is 25 teaspoons. Obviously, we want to adjust that number so that we can use the largest possible measuring tool when preparing the recipe. In this case, we know that there are 3 teaspoons in every tablespoon. So I can begin the adjustment by dividing 25 by 3 to get 8.33 tablespoons. Because we cannot easily measure 8.33 tablespoons, I need to round to the closest measurable amount, which in this case could be 8 tablespoons. It just so happens that 8 tablespoons is equal to half a cup, which is the most efficient measurement. I use the same process for all remaining seasonings. At this time, feel free to pause the video, review your individual answers, and then discuss as a group. Press play when you are ready to proceed. Welcome to the final section of Culinary Weights and Measures, portion control. Take a few minutes to think about why correct portioning is important. Go ahead and pause the video, and when ready, share out and discuss as a group. Press play when you are ready to proceed. Welcome back. Let's review some of the reasons that portion control or correct portioning is important. 1. Correct portioning ensures that you are serving menu items as planned and meeting federal school nutrition guidelines. 2. Portioning is directly related to recipe yield. If you overportion, you will run out of food. Conversely, if you underportion, you could have an excess of leftovers. Both of these issues can be detrimental to your bottom line, especially if inaccurate portioning is commonplace in your kitchen. Finally, incorrect portioning can negatively impact guest satisfaction. If one guest or customer receives a heaping spoonful of mashed potatoes and the next guest in line receives less, the guest who receives less feels offended or as if they didn't get their money's worth. So what can kitchen staff do to ensure they are serving the correct amounts of each food item? For one, staff should use portioning tools that measure food items in both cups and ounces, or in other words, in both volume and weight. Second, managers are encouraged to bring their staff together periodically for brief demonstrations and practice sessions. For example, a manager might bring their staff together before the beginning of service one day, have each staff member portion one of the day's menu items, and then weigh each portion to determine the accuracy. These sessions don't need to be long. 5 to 10 minutes is more than enough. Finally, take advantage of the plethora of portioning guides and resources available, such as the At a Glance poster mentioned earlier. Okay, you made it. This concludes the instructional portion of the Culinary Weights and Measures video. Now you get to have some fun and practice what you've learned with a game of bingo. For the majority of you who've played bingo before, you know that in a typical bingo game, each player gets a unique bingo card containing squares with different letter and number combinations. Every time the host calls out a combination that you have on your card, you get to cover that particular space. The bingo game we are playing today is very similar, except instead of a letter number combination, your instructor will read a question. You must figure out the answer to that question, and then if you have that answer on your bingo card, you may cover the space. Before you begin the game, let's go over a couple of ground rules. First, please refrain from talking or saying the answer aloud after the instructor reads the questions. The instructor will give everyone time to find the answers and then ask for a volunteer to share the correct answer with the group. To win the game, you must be the first person to cover 5 spaces in a row, vertically, horizontally, or diagonally. You will be using the dried beans your instructor provided to cover spaces on your card. Once you have the required spaces covered, shout out bingo, and your instructor will confirm the answers before naming you as the winner. This officially concludes the Culinary Weights and Measures video. I hope you gained some useful information and were able to build and refine some of the math skills that are so important to day-to-day kitchen operations. Don't forget to check out all of the great resources included in the participant workbook. There are several resources you can print and post in your kitchens. Also included are a variety of activities you can use to train your staff, complete with answer keys. Thank you again for taking the time to strengthen your skills in kitchen management and operations. At this time, the instructor may stop the video, distribute one bingo card to each participant, and begin the game using the bingo questions located in the instructor guide. Have fun, and thanks for watching.